Hello everyone. Thank you for joining me today on this webinar. I'm Karthik Tota. I'm a senior document DB specialist solution architect at AWS. Today I'm going to talk about two new feature launches in Amazon Document DB. Developers are turning to document-oriented databases as it is easier for them to store and query the data that seamlessly evolves with their applications. We built Amazon Document DB with MongoDB compatibility because our customers wanted to manage their JSON workloads at scale. I'll start the session by providing a high-level overview of Amazon Document DB to help the people who are new to it. And next, I'll talk about what's new in Amazon Document DB, and then I'll introduce and dive deep into two of our newest features, DML query auditing and Decimal128 data type. Finally, I'll cover how the new users can get started with Amazon Document DB for free. Let's start with what is Amazon Document DB. AWS offers 15 plus purpose-built database engines to support diverse data models. Enterprises do not want to settle for database that does a lot of things okay and none really well. This all has led people away from using relational databases for every workload and instead using the database that is really great at what each application needs. Amazon Document DB is a purpose-built document database that is scalable, highly durable, and fully managed database service for operating mission-critical document database workloads or MongoDB compatible workloads. When customers ask us why we should use Amazon Document DB and what are its benefits, we would like to think of three pillars. First one being the speed and scale. Amazon Document DB is fast and scalable. Customers can scale compute in minutes with Amazon Document DB. The separation of storage and compute means your storage and I/O can grow automatically based on your workloads. For example, storage scales from 10 GB to 64 TIB regardless of how large or how many compute instances you have. There is no command, CLI, or operation you need to interact with storage volume. It is all managed by AWS. For customers who are looking to support millions of read requests per second, can scale out compute layer to 15 replicas within minutes. And your document DB workload now has the ability to be distributed globally to up to 5 regions for disaster recovery from a region-wide outages and lets you to do low latency global reads. The next pillar is the management. One of the pain points we hear from our customers while working with the databases such as MongoDB on-prem or on EC2 is the management. Database management is not trivial. Customers do not want to manage the complexity of managing the upgrades, backup infrastructure, ensuring the high availability, managing the monitoring infrastructure, and other undifferentiated heavy lifting tasks. Amazon Document DB is fully managed. Patching is automatic, monitoring is native, and integrated with enterprise services like Amazon CloudWatch. Backups can be enabled by default to provide you comfort and peace of mind. High availability is built in with 6 copies of your data stored across 3 availability zones, and you get encryption at rest and in transit enabled by default. The third pillar is the MongoDB compatibility. This is important for many of our customers as they bring a lot of workloads that are developed using MongoDB. DocumentDB supports MongoDB workloads and is compatible with MongoDB API. It is a logical choice for MongoDB users who are looking to easily migrate to a fully managed database solution. You can use the same tools and the drivers that you use with MongoDB to work with DocumentDB. You can lift and shift your applications to DocumentDB with little or no code change. Please note, Amazon DocumentDB is not MongoDB under the covers. It's built ground up as a cloud native database at AWS. We support hundreds of APIs, operators, and aggregation stages. And if you are using any MongoDB operator or an API that is not yet supported, please do let us know, as we are always working backward from what our customer wants. And Amazon DocumentDB cluster provides 99.99% of availability, that is 4 nines of availability, and can handle tens of thousands of writes per second and millions of read per second. And it supports up to 64 TIB of data. Let's see some of the Amazon DocumentDB customers. We have been GA since January 2019. Since then, lot of customers from small startups to Fortune 50 organizations are using Amazon DocumentDB for their mission critical applications. Customers include global organizations like Capital One to digital natives like Rappi and Zuli to game publishers like Happy. In addition, several products that Amazon customers use, such as Fulfillment by Amazon, Ex- Experience on Amazon, are powered by Amazon DocumentDB. We have customers virtually in every industry, from financial services to retail, from gaming to manufacturing, from media and entertainment to publishing, and more. Let's talk about Amazon DocumentDB architecture to understand how it is designed to support the workloads at scale. As I said before, DocumentDB is built ground up at AWS as a cloud native database service and is built to leverage the scale of cloud. At a high level, it is architected to separate storage and compute so they can be scaled and managed independently. In traditional database architectures, storage is attached to the compute. And in order to scale the cluster, you need to copy the data, and the time required to scale is proportional to the size of the data and the network bandwidth available with you. But with DocumentDB, using cloud native architecture, you can scale the compute in minutes. DocumentDB storage auto-scales as your data grows and is spread across 3 availability zones to provide high availability and durability. Each availability zone maintains 2 copies of data, making a total 6 copies of your data. Another advantage of this cloud native architecture is that replication is offloaded to the storage layer, which frees up the replica instances for more read capacity and more query processing. It also lets you perform durable writes irrespective of the number of instances attached to the cluster. When you write data to DocumentDB, you write to primary instance. And DocumentDB uses a write quorum of 4. And after 4 copies of data is written to storage, the primary will send an acknowledgement to the client. All writes to the DocumentDB are durable by default and you are not able to change it. DocumentDB maintains a read quorum of 3. Now let's see how Amazon DocumentDB handle failures and how backups are done. Let me start with the compute. If a primary or a writer node fails, an existing replica in the cluster is promoted to primary, and a new instance is launched to replace the failed instances, which will come up in 8 to 10 minutes, bringing the cluster back to its full capacity. If a replica instance fails, it is replaced with a new instance and there is no need of a failover. As there is no data to be copied between the instances, the cluster would be back to the full capacity in less than 10 minutes after a failure. Coming to the storage, Amazon DocumentDB uses unique distributed fault-tolerant self-healing storage system. When a segment of a cluster volume fails, Amazon DocumentDB immediately repairs the segment using the data from other volumes that make up the cluster. Backups in DocumentDB is different than how traditional backups are performed. DocumentDB backup has no impact on the performance because we stream the data from the storage layer. It means backup is also offloaded to the storage layer. We perform continuous incremental backups at every 5 minutes and full backups to S3 so that we have fine granularity with incremental backups and faster restore times with the full backups. And as the backups are streamed to S3, they are highly durable. Now let's see the timeline of feature launches with Amazon DocumentDB. Innovation is central to AWS approach, and we continue to listen to our customers to build new features to meet their enterprise needs. Since 2019 service launch, we have expanded to 18 AWS regions and have launched key features such as the ability to perform ACID transactions across multiple documents, statements, collections, and databases. We added support for role-based access control with user-defined roles, which gives you granular access control as well as the ability to create custom roles. We introduced global clusters that provide disaster recovery in the unusual event of a region-wide outage. Performance Insights allows you to quickly access the load on your database and determine when and where to take an action. With database cloning, you can create the clones to enable fast creation of new clusters that uses the same DocumentDB cluster volume. This is faster than restoring a snapshot and requires no additional space at the time of creation. We have also recently added support for Decimal128 data type and additional query auditing support for database events. Now with DML auditing enabled, in addition to DDL events, DocumentDB will record DML events to Amazon CloudWatch. Working backwards from the requirements of customers operated in highly regulated industries, we built auditing feature to DocumentDB and expanded its features. DML query auditing is an extension to the existing auditing capabilities. With the new addition, DocumentDB now lets you to audit reads, updates, inserts, and delete operations, DDL events, and authentication informations to Amazon CloudWatch logs. You can see who accessed or modified the data, or when a role was changed, or when a new user was added, or even a successful or a failed login attempt. There is no additional cost to use the DML auditing or DDL auditing. You pay the standard rates for use of Amazon CloudWatch. Document DB auditing lets you to choose the events to audit. You can go for all events or specific events or a combination of specific events. For example, you can choose to audit only DDL events or only read events or write events, or you can select a combination of DDL and read, DDL and write, or read and write. Please note, TTL deletes are not currently audited. With tight integration with Amazon CloudWatch, there is no need for you to use primitive tooling or scripts or third-party tools to access and analyze your audit logs. You can all do with Amazon CloudWatch. Let's see some of the use cases where auditing is needed. Organizations operating in regulated sectors need to audit database activity for two main reasons: to achieve compliance like SOX, PCI, and HIPAA, and to enhance security posture. Maintaining the audit trail of data changes and access privileges for specific duration is one of the SOX requirements to help analyze any incidents involving the regulated data. The audit trail should contain enough information to identify who, what, when, how, and where the data is accessed or altered. And for security, administrators want to monitor for specific events and get alerted when an event like deletes or drop happen on the database. Before moving on to a demo, let's see some of the sample events and important fields of the audit trail. Here we are seeing an example of audit trail for a DDL event. Audit trails for some events may contain more information than the other, but all the audit trails will have enough information to identify who, what, when, how, and where the data was accessed or altered. The left one on your screen is the audit trail for an authentication event. It shows the user with the primary user as a username has logged in from a remote IP 10.20.2.124 at a particular timestamp mentioned on the TS. This is a Unix timestamp. And whether it was a successful or a failure, you can see from the success key. So this, the left one, what you're seeing on the screen is a successful login event for a primary user at a particular time mentioned on the TS. And on the right side, you are seeing an audit event for a create collection. It also have the event type, the time, the source from where the event has originated, and the user who has responsible for that event, and on what namespace the event has been applied. So the right side, the create collection event, we can see that it is executed on catalog database, and the create collection is the products. Now let's see an event for a DML insert. Please note here, for DML events, the action type would be the auth check, and the related event can be found whether it in the param subdocument. So from this audit trail, we can see that the insert is performed on the namespace catalog.products, and the data is mentioned in the document array in the subdocument of param. And in all the events, you are able to identify who, when, how, where, and what was changed, or what was accessed, or what was altered. Now let's look onto a demo of DML auditing. In this demo, I'll walk you through the process of enabling the DML auditing on Amazon DocumentDB cluster. Please note, DML auditing or DTL auditing is not enabled by default. And after enabling the auditing, I'll show how to analyze the audit trials on Amazon CloudWatch logs, and also set up alerts to get notified when a delete happened onto the database. To start, your cluster should be configured to use custom parameter group. If not, create a new cluster parameter group and assign to your Amazon Document DB cluster before proceeding for enabling DML auditing. DML auditing is not enabled by default, as I mentioned, and to enable, it's a two-step process. Here, I'm using a DML auditing named cluster to demo you the DML auditing. So my cluster is already using a custom parameter group uh, name docdb 40DML. And to enable DML auditing, it's a two-step process. The first step is to update the dynamic audit logs parameter in the custom parameter groups to allowed values. And the second step is to enable Amazon Document DB to export audit logs to CloudWatch. So let me move on to the first step to update the custom parameter group parameter audit logs. So I'll locate my parameter group docdb40dml in my list of cluster parameter groups, and I choose the audit log, and I select edit, and I provide one of the allowed values. I'll be using all for this. You can use DDL or DML read, DML write, or DDL DML or DML read, DML write. Please don't use enabled and disabled. They work for now, but they would be soon deprecated. And I can choose to apply immediately because this is a dynamic parameter. It will not be impacting my cluster availability. So I choose to apply immediately. Have, make, and I completed the first step. And the second step is to enable Amazon Document DB to export audit logs to CloudWatch. So I get back to my cluster. I choose the cluster, and from the actions, I modify it. And to the log export, I choose audit logs. And I continue, and I will apply this change immediately. So I'm changing. You can review your modifications here. What are the attributes that are you are modifying? From disabled audit logs, I'll changing it to enabled audit logs. And this is also a dynamic parameter, so you can enable and disable without the need of restarting your cluster. And now I modify the cluster. Let's see if it has been applied. If we go to configuration, let me refresh it. It's applying. Give it a few seconds. So I applied the CloudWatch log exports, and I can see that it has been applied by going to the configuration, and I can see the CloudWatch logs enabled as audit. It means I have enabled my CloudWatch export successfully. And now I enable the DocumentDB DML auditing on my cluster. Now the next step is to create some activity. For that, I log into my DocumentDB cluster using a Cloud9 terminal. This is a browser-based terminal. You can use any terminal of your choice to log into your DocumentDB. And please note, I'm using the same document DB cluster I'm showing you here. And I log into my DocumentDB, and I log into my primary. And I insert few records to it. Before that, let me show you this is an empty cluster and empty database. No database exists. I create few records. I create a database and insert few records. So I created a database, use catalog, and I inserted 5 records into the products collection, and those are successfully inserted. I have now 5 records inserted. Now let's see how this information looks on the audit trail. I go to my CloudWatch logs, and I refresh to see a CloudWatch log group with the name of my cluster/audit that gets created. And then I'll go to see my all the events. I search all log streams, and I see the events that got generated for my activity. See, the first step I did was authenticate logging into my cluster. So the A type was authenticate, as we have seen on the sample event. So this event authenticate has happened, and then the next step I did was a create database with use catalog command, and then I inserted records into the collection. As the collection is not existing, so DocumentDB created a collection and inserted the records. If you want to filter out a specific set of events, like I'm only interested in insert events, I can run this filter command to filter out the JSON data. This is a standard syntax to use, and I'll filter out that events of only insert. Now I am only filtering out the insert events. So this is the insert of 5 records that has been audited. Now let me try and execute a delete on my database so that I capture it on that. I go ahead and delete the record. Now it is only 4 records we have. Let us see if it has been captured on the CloudWatch logs. And now I use a filter just to identify the deletes. Instead of insert, I'll mention delete. See, it has been captured. Now I want to create if alert if such kind of events happen. See, we the audit trial for the delete has been captured. So now with this filter expression, I'll create a metric filters, and I provide some name, DocumentDB NS, provide some namespace, and provide some metric name, and I'll keep the metric value to minimum 1, and I'll leave the remaining optional values and I click on create. Now a metric filter has been created. Now I'll use this metric filter. To use that metric filter, I go to my CloudWatch log and I go to the metrics filter and I have my metric filter created on the previous step. And to create an alarm, I'll select this metric filter and I choose to create alarm. And I need to be notified immediately. So I choose my period as 1 minute. I don't want to attract more cost on the CloudWatch. And even if one delete happens, I need to be notified. So I use greater than equal to threshold of more than one event, more than or equal to one event. And I click on next. And I choose an existing topic that I have. This is I'm using the SNS topic to notify me when this delete happens. And I give a meaningful name, deletes on catalogs DB. Delete commands executed. Select next. Everything is fine. I select on create an alarm. Now the alarm is created. Now let me go ahead and delete one more record. Back to my Cloud9. I'm removing another record with SKU 3243662. And it is removed. Let me see if we can see that in my filter. Go to my CloudWatch. Now I have two deletes executed on the database. Now this second delete should trigger an alarm. If we go to the history, we can see it executed. See the my deletes on catalogs DB alarm is in alert state, is in alarm state. The action successfully executed on this. So I'll be getting a notification for the subscribers subscribe to that SNS topic. In this way, we can enable the DML auditing on a Amazon DocumentDB cluster and also analyze for the events, and we can also create alarms over those events. Now, let me move on to the next topic, the Decimal128. Customers in financial and scientific sectors needed to perform high precision calculations and they needed the support for Decimal128 data types. So we built in that support for Decimal128 for our enterprise customers and other customers. Decimal128 is a BSON data type and provides 128 bits of decimal representation supporting 34 decimal digits of precision. With Decimal128 support, you can store the exact values in the database, eliminating the rounding errors. Let us see a demo on how Decimal128 can help avoiding the rounding of errors and store the exact values in the database. In this quick demo, I'll show you how Decimal128 would store the exact value when compared to the double and what is the right way of storing Decimal128 values in the database. Back to my Cloud9. The first thing I would show is the correct way of storing the decimal 128 value. Here I am using a large value, and to store the decimal in decimal 128 format, you need to use the number decimal keyword, and the value should be passed in the quotes. This is the right way of storing the values. And let's see how it is stored. It is stored exactly the way we have asked it to store, no rounding offs. So now let me show you how it was earlier with double. So I am with this I am inserting into three formats. So the first one is the right format to store the value in decimal 128 format. The second one I'm storing it in the double format, and the third one I'm storing in the number decimal, providing the number decimal but without the quotes. Let's see how the result looks. In the first attribute, the value is stored exactly the way we asked to store. And in the second one, it which is stored in the double format, it has rounded off. And in the third, without the quotes, it rounded off. We lost the precision. So the right way of storing a new decimal 128 is to provide the value in the double quotes. And let's see some more examples. I'm using a very large number here. Then in the number decimal, the value is stored exactly the way we have asked it, we have submitted. And in the double, it has stored in the scientific format, losing the precision even. And even the similar thing with the when we stored without the quotes. So what happens if we store the number beyond the capability or beyond the range of decimal 128? Let's see this. I'm giving a very large number that is beyond the range of decimal 128. You get an error. It is not rounding off. So decimal 128 will not round off. But what happens when we give the same value uh, for double and without the quotes? That gets successfully inserted, but you lose the precision. Let's retry it. You have lost the precision because it is stored in the scientific format. So in decimal 128, if you are trying to store the decimal 128 that is beyond the range of decimal 128, you get an error. So this is the short demo of decimal 128. Now let's move on to the next topic of getting started with Amazon DocumentDB free trial. In January 2022, that is this year, we launched Amazon DocumentDB free trial because we want all our customers, enterprises, individuals to feel confident when they sign up for Amazon DocumentDB. With free trial, you get 750 hours per month of P3 medium instance usage, 30 million IOPS, 5 GB storage, and 5 GB backup for free for 30 days. Once the 1 month free trial expires or your usage exceeds the free allowance, you can shut down the cluster to avoid any extra charges, or you keep it running at our standard on-demand rates. So that's all I have for today in this webinar. Please let me know if you have any questions.